3.6 equation of tangent lines. This lesson will be pretty much the same as 3.5, but we're taking it one step further and actually writing a linear equation of the tangent line using the slope that we find. Okay, so our function is f of x equals 10x squared minus 10x plus 12. I have it graphed below, but that is something extra I put down there. That won't be on Delta Math. But they want us to find the slope of the tangent line at x equals 10. So we're finding the slope of a curved function, because this is a quadratic, at a specific x value. That means we're using the tangent line slope formula, which is actually the difference quotient. So to find the slope of the tangent line, we're finding actually the limit as that arbitrary h number goes to basically nothing. And that is taking the second y value, which is f of x, plus that h number, minus that first y value, which is just f of x, and it's divided by h. And so what I would suggest is for this piece right here, f of x, find what f of 10 is. And then we don't have to have so much in our formula. So f of 10 would just be plugging in 10 here. So it'd be 10 times 10 squared minus 10 times 10 plus 12. And so we get 912. So that will go right here. Okay, but let's go ahead and first I'm getting a little ahead of myself. I'll plug in 10 for the x's. So we got f of 10 plus h minus f of 10 over h. So the first thing we want to do is put 10 plus h n for x everywhere in our function, which will be 2 different times. So it'll be 10 times 10 plus h, quantity squared, minus 10 times 10 plus h plus 12. So that's that whole function. And then minus our y value when we plugged in 10, that's 912. Hopefully everything will cancel out. That's how you know you're doing it right. These things will really simplify here in a minute. 10 plus h quantity squared, that would be 10 squared is 100. 10 times h is 10h doubled, would be 20h plus h squared. And times 10. Distribute the negative 10 to 10, that'd be negative 100 minus 10h plus 12 minus 912 all over h. Trying to write smaller. And then distribute the 10. I'm going to go over here. 10 times 100 would be 1,000. 10 times 20 would be 200h plus 10h squared minus 100 minus 10h plus 12 minus 912 all over h. All right, so let's see what's happening. We've got our 10h squared. We've got 200h minus 10h, which would be 190h. And then we've got 1,000 minus 100 plus 12 minus 912. Yep, that made 0, so those are gone. And then we want to factor out an h. So your choices are to either take out an h from the top and then divide that away, or just divide each term by h right here. I like to just go on and divide them out. So h squared divided by h will now make this an h. H divided by h makes this go away. And remember, this is still finding the limit as h goes to 0 of 10 h plus 190. So we'll put in 0 for 10, or for h, sorry. 10 times 0 is 0 plus 190, so it's 190. That is the slope. So we're going to need that to write an equation of this tangent line. And hopefully, remember back from algebra, there's this point slope form. When you have a point and you have a slope, you plug this in, plug it into here. And so it goes y minus our y1. Well, our y1 went all the way back with this ordered pair. We had a point at 10, 192. That's the point we were trying to find the slope at. Let me write down here again, 10, 192. And so our y value out of that would be the 192 equals m, the slope was the 190, times x minus the x value of our point is 10. And we don't need to get it into y equals mx plus b. They're okay with you leaving it like that. You could distribute the 190 to the x and the 190 to the negative 10 and then add 192 over. You could do that, but you don't have to. What that would be is, let's see, that'd be 190x. 190 times negative 10. And then add 192 to that. I'm showing you this because I want you to have a good visual of what's happening. Did I do that right? 190 times negative 10, and then you would add the 192 over. That's really the y equals mx plus b form. So what's happening is this is the graph of the curved function. They're wanting to know the specific slope at x equals 10 and make some kind of line here. Well, that's hard for us to do with one point, but I'll show you kind of what it would look like. The tangent line would be something like that. And we're actually just writing a line or an equation of this linear function, this tangent line. And so it looks like our slope is positive 190. It is pretty steep, so that looks like maybe we're going up 190 over 1. The y-intercept is very negative because if I continued this line way down here, yeah, I would be way negative. So that makes sense. Okay, but the answer they're looking for is either this, or if you want to take the time and put it in slope-intercept form, that's fine as well.